In this class, I want to discuss strain energy stored in an elastic material. The strain energy stored. The strain energy stored is giving us half Fe. I can call this equation 1. Then recall that stress is giving us force over area. I want to make force the subject. So I want to make this term the subject. Force will give me stress times area. Call this equation 2. Okay? Then also recall that strain is giving us extension over original length. I want to make E the subject. Extension becomes strain times original length. Call this guy equation 3. Also recall that your modulus is giving us stress over strain. We have stress over strain. I want to make strain here the subject of the formula. If I do that, I will have strain to give me stress over your modulus. That is stress over your modulus. Call this equation 4. Okay? Substitute equation 4 into equation 3. So meaning that wherever you see strain, you substitute stress over your modulus. So the extension becomes strain, which is stress over your modulus multiplied by L0. Call this equation 5. Now we're going to substitute equation 2 and equation 5 into equation 1, meaning that wherever you see force, you substitute stress times area, cross-sectional area, and wherever you see the extension, you substitute this term there. If I do that, the strain energy becomes half into force, which is stress times area, okay, times extension, which is stress over your modulus times original length. Okay, that is that. So strain energy becomes half into stress times stress will give me stress square. So I'm going to have stress square into A times L0 over this. So you have A L0 over your modulus. So this is the strain energy, which is equation 6. This is strain energy stored in the material, okay? So having known that stress is force over area, we can also substitute force over area into this equation to modify equation 6. So if I do that, I'm going to have this. Knowing fully that stress is force over area. So wherever I see stress, I will substitute back to that equation. So strain energy stored becomes half into stress is what? Force over area. In this case, it's going to be force square over area square because of this square multiplied by area, this L0 over your modulus. Okay, now one of this will clear one of this. You now have strain energy will give me half into F square. We have the F square L0 over A of this. So call this equation 7. Equation 6 and equation 7 are the strain energy stored in an elastic material. Thank you. Subscribe to our YouTube channel and follow us on our Facebook page. Share us and like us. Thank you.